Okay, listen, before we do anything, what do you what do you think integration does? Do you know what integration is? Kirsten, you know what integration is?
It is like something to do with area and volume, but
But like, yeah, you're not wrong, that's correct. But at its core, what is integration? What was the
mm,
previous topic we did? Tell me, Kirsten, what was the previous topic we did? What was the previous topic
bit
before integration?
inflection,
Um, the whole topic, the general topic. So that's a D. What was before
different
integration?
differentiation.
Right. So integration is just the opposite of differentiation. That's what I wanted to hear. So, um, here what? Oh, wait, to differentiate 5x squared for me. Differentiate that. How would you differentiate 5x squared?
It'll be 10
It would be 10x. So tell me what you do. What did you do to get the 10x?
5x by 5x to 10x.
No,
Well, 5 by 5 is 10 at the end.
no. 5 by 5 is not 10. 5 by 5 is
So
25.
25. 5 by 25, yeah.
So, but this is the correct answer. So how are we getting the 10? How are we getting the 10? Do you know how to differentiate?
It will be like 5 and next it will be the D that I graded, like D over dx.
No, nah. Listen, you have to check back on videos. When we differentiating, we're taking the power, we multiplying it by the number in front, and then we taking away one from the power. So 5 by 2 is 10, and we take away one from the power, so the power is 1 now. Try this one, right? So dy dx. If I differentiate that, what would I get?
So it'll be 6 by 6 is 36, 36. So that's like
Wait again, 6 by 6 from.
6
Check.
by 6 by 6 by 6.
Nah, check it out again. We are taking the power and we are multiplying it by the number in front. So
3
5,
by 6 is 18.
right? And we're taking away one from the power. So 3 minus 1 is?
2.
That's the answer. So when you differentiate, you multiply by the power and then you minus 1 from the power. Integration is just the opposite of that. Aliyah, good morning.
Hi.
Hi, is everything all right?
Yeah.
Okay, cool. So Aliyah, we're gonna start integration today. Um, you would have missed out points of inflection on thing.
Yeah, from last class, yeah, because I had to leave early.
I know. I hear something was wrong with you. I wasn't feeling
Yeah.
well. Are you feeling well today?
Yeah, I better. This.
Okay, that's good. So, and you know what differentiation is, like basic differentiation?
Yeah.
Well, integration is just the opposite of that. So
Mm-hmm.
we're gonna start integration. So I want you to try to understand what's going on here. So Aliyah, imagine if I had the function y is equal to 7x cubed. How would I differentiate that?
You multiply the power of x by the coefficient of x.
Right?
So that's 21. And then you minus 1 from the 3. So that's 2.
So what would be the opposite of that? So in differentiation, you multiply and then you minus. What would be the opposite of multiply and then minus?
You divide and add.
Right. So let me see what happened. So what if So in integration, so I would write it like this, integral of 21x squared dx. So the first step here was to multiply, right?
Mm-hmm.
And then minus. Well, what we're going to do is we're going to add and then divide. So I would add
Yeah.
1 to the power and then divide. Do I get back the original thing?
Yeah.
Right. So just by looking at that, integration is the what of integration is the what of differentiation. Is the what?
The the opposite.
Right. So we use integration to reverse differentiation. But anytime we differentiate, we need to put a plus c. And you all will see why we need to put a plus c just now. Matter of fact, I'm going to explain it here. So Aliyah, if we integrate dy dx, we're going to get back what?
Why?
You're going to get back y. But let me try something. Imagine if you had y is equal to 3x squared plus 4. Differentiate that from
Um, 6x
plus. You
0.
differentiate 4, 0, right? So we lose the 4 completely, didn't we?
Yeah.
So if we go to integrate this now, so if I go to integrate 6x dx, what am I going to get?
Um,
Say add 1 to the power first and then divide.
so you're gonna get 6x squared over 2.
Right, but we don't have anything again, right?
No.
No. So, but and in the original thing, we had plus 4.
Yeah.
What's the only thing I'm getting back? What's
The
the only thing
3x
I'm
squared.
right? So what I need to do is I need to put a plus c to account for any lost constants because I would have lost the 4, right?
Yeah.
And on the left-hand side, since we integrate dy dx, we're gonna get back what?
Y.
Yeah. So that's the concept there. So I would like you all to copy down the notes. The notes summarize all of that. So integration. So what is it? I want to let you copy down everything here. Right? So integration. What is it? Integration is just the opposite of differentiation. You add 1 to the power and then you divide. So example, if you had y is equal to 5x squared, you differentiate it 10x. Right? And if I integrate, by the way, guys, if anybody isn't aware, this symbol over here, that's the integral sign. You know how you would write d dx for differentiation? Well,
Mm-hmm.
it's the integration sign. And in differentiation, you would write dy dx because you're differentiating y with respect to x. Over here, check this. Aliyah, if I had dA dy, that means I would have been differentiating a with respect to,
Y.
so I'm integrating with respect to y.
Mm-hmm.
Yeah, you need to keep that in mind. So let me just say I was integrating 5x squared. I'm integrating with respect to,
Y. With no x.
right? If I had 5 theta cube, that would be
Differentiated with
no,
respect to theta.
not differentiating. It's I'm integrating with respect to
Oh,
theta.
okay.
D means with respect to,
Okay.
right? So copy this down, right? Kristen, if anything is confusing you at all, let me know. So integration is just the opposite. Instead of multiplying and then subtracting, you're adding 1 to the power and then you divide by that number. So Leah, I'm gonna ask you a question, right? When you find the equation of a line, what is really thing is that a find for? Like after you find the gradients and saying, what's the one thing it doesn't know?
Um,
So like we just say you have a point on the line and you have the gradient. What's the one thing it doesn't know for? What's the one thing is that a find?
see,
Oh yeah, do you know? So remember, what's the equation of a line?
y is equal to mx plus c.
So if we have a point, that what I mean, what that means we have. What does that mean we have? If we have a point on the line, that means we
A
have what two
point.
values.
You have your x value and your y value.
And if we find the gradient, that means we have
The difference.
no, if we have the gradient, that means we have m, right?
Oh well, yeah, yeah.
So is the one thing we don't have in that equation of the line?
C.
Right. So when you integrate, it's the same situation. Look at that.
Yeah, yeah.
You'll have a point on the line, and what's the one thing you won't know?
C.
C. So they'll give you a point, and they'll tell you to find for C, and you'll have to do that. So that's typically how the questions answers go. Right? Amy, good morning.
Good morning.
What's up?
Nothing much. I just oversleep because I come home kind of late yesterday.
Oh,
Yeah.
enjoying yourself, partying.
No, I going to work with my parents.
Okay, never mind. You're hustling. Respect.
Yeah. Also, I found out about the advanced exam. I don't know what the teacher actually say, but the head of the department said that he would tell him about it. So yeah, when I have my first exam next week after I could find out,
Okay,
like which is on Tuesday.
all right, no problem. I have to go. I have to correct the easy test. The easy test I gave you.
Mm.
Did you start preparation to start the advanced test?
Yeah.
Okay, nice. So once you can do that test, I think you'll be okay. I think you should be fine. So Amy, you have all of this, right? You, this was notes. This is the notes I did with you.
Yeah.
So what I want you to do is I would like you to start some integration questions.
Okay, because I did stop with the past papers. I think I stopped at 2016 or something.
You have the integration questions, right?
Yeah.
Okay, good. Right. So Aliyah and Kirsten, as soon as I finish copying down these notes, just let me know. We'll continue.
I finish.
All right. Okay, wait. Kirsten, did you finish copying on everything that's on the screen?
Yes, sir.
When I mean everything, like the arrow one thing, like
Yes, sir.
okay, good. All right. So let me look at an example now. So this is why I'm saying we need to put plus C. If you don't put the plus C, you're gonna lose our mark. Or if your teacher is like a later teacher, they'll give you the whole thing wrong. Okay. So Aliyah, let's run through this. So the original function is y is equal to 3x squared plus 2. If I differentiate this function, I'll get 6x. Where did the 2 go?
You minus one
No, but where did the
from
2 go? Where did the 2? The 2, the constant, none of the power.
oh um
The 2
when you
just disappeared.
differentiate when you
Yeah, well,
differentiate it, you
mhm,
would you would get 0.
right. So suppose we get an expression like y is equal to the 6x, or dy dx is equal to 6x. And to kind of have a constant before we differentiate it. Let me say that
Yeah.
again. If you're looking at this expression, could you could you tell me if it had a constant before we differentiated? If this wasn't here, you'd know that?
No.
No, you'd have tell me y is equal to 3x squared, no?
Mm,
Because when you integrate,
no.
and when you integrate, it'll be 6x
You will
squared
get,
over 2.
yeah, so
And
you'll just get 3x
yeah,
plus,
but we don't know if it had a constant, so you need to put plus c anyways, right?
yeah.
So that's what going on. That's really what going on. And we call this type of integration indefinite. So this is indefinite integration, right? So I would like you all to copy this down. So again, let's just say you have our original function, and this function had a constant in it. Anytime you differentiate, you lose on constants because constants, they are constants. Nothing changes. So if we differentiate it, it's 0, right? And so you end up with something like 6x. But if you go to integrate that to try to undo the differentiation, it'll only take you so far because you'll only end up with any terms that had x in it. It wouldn't account for the constants I lost. So you need to put plus c. And earlier, what I'm seeing is any question, it'll give you a point. They might give you a 2, 4 or something. And they go say, using these points, find for c and write the complete equation. You think you would know how to find for c given those points, 2, 4?
Yeah.
How would you do it?
Um, will you use the points that they give you?
Right? So what would be x and what would be y?
X would be 2 and Y would be 4.
Yeah. You plug that in, you find for c, that's it. That's it.
Yeah.
All right, Aliyah, you everything copy down?
No, I understand.
All right.
I finish.
All right. Kirsten, what about you?
Yes, sir.
All right. Amy, how are the integration questions coming along?
They're going good so far. I just correcting what I have so far to make sure I do the correct thing.
All right, no problem. I didn't do finite integration with you as yet, so you probably wouldn't know how to find the area and volume.
Mm-mm.
But it's real simple. Real simple. You could look it up online and see if you could figure it out, or look at the
Okay.
solutions. I promise you, it's real simple. All I had to do, right? Let me explain it quickly. With finite integration, let me just say I had to integrate 5x squared 1 2 1 0. What I mean is you're gonna integrate it. So like I go integrate it like normal, and that'll be 5x cubed over 3,
Yeah.
right? And all we're gonna do is our upper limit is 1, so I'm gonna put in 1 into that. So 5 by 1 cube all over 3. Then I'm gonna subtract it from the lower limit when x is 0. And that's it.
Oh, okay.
And that is how you find the area. That's how to find the area as well. So that's finite integration. All you're gonna do is you're gonna integrate like normal. You're gonna take the upper limit, plug it in, and then put in brackets, and then subtract it from the lower limit. So you could do
Oh,
it, right?
okay.
Right? I'll leave this for you here. I'll leave this here for you so you can copy down the correct working. So when you finish integrate, you have to put square brackets, put 1 on top, put 0 in the bottom, well, whatever your limits are, and then do that.
Yeah, I just want to take it down really quick.
All right. So, Aliyah, I want you to read this part for me. What are they saying here?
If you wanted to find for C, you'd need initial condition.
Right. So what initial conditions are, they're just they're just conditions that would satisfy this equation. So, and you want to get back this? You want to get back this, right?
Yeah.
So we want to get back C. So what you would have to do is they would have to give you a point on this curve. So Aliyah, you think if I put x is 1 and y is 5 into this equation, you think you go satisfied?
Um,
Remember, we want to get back the exact equation. So you would give conditions where the point is on the curve. So if the point is on the curve, will it satisfy the curve?
if the point is on the curve,
Yeah. If the
yeah,
point, yeah, it would. Try it. So we're saying that x is 1 and y is 5. So we're saying that x is 1 and y is 5. So 5 is equal to 3 by 1 squared plus 2. Would that be equal? Three by 1 is 3. 3 plus 2 is?
5.
So it's 5 equal to 5?
Yeah.
Right. So an initial condition is a condition that satisfies the equation you want to work towards. And you want to get this equation?
Mm-hmm.
So they would give you a point that was on that curve. And that's what you're gonna use. Are you understanding?
Yeah.
So here what to do for me now. I want you to find for C when x is 1 and y is 5. So do that for me. And we're expecting C to be? C is supposed to be what?
5?
5?
No, C supposed to be 2.
C is supposed to be 2. So I want you to
Yeah.
find, using those initial conditions, x is
Okay.
equal to 1 and y is 5, find for C. And then write the final equation.
I get it too.
Right, nice. So Alia, let's just run through it, right? Kirsten, all clear right here. Right, so let's just run through everything. We started integration and we said that integration is just the opposite of differentiation, and we use integration anytime you want to find the original function y or f of x. We could also use integration to find area and volume. Everybody okay with that, right? Alia, you good?
Yeah.
So Alia, why do we need to put plus c? Explain that fast. Why do we need to put plus c?
Um, to cater for all the what is called for the things you lost.
Okay, what do we lose when you differentiate? What do you lose when you differentiate? How to see?
Once.
Constants, you lose constants. So you put plus c to cater for any lost constants. So when
Yeah.
you integrate, it will only give you the terms that had x in it. It would not give you any constants that you lost. So to
Mm-hmm.
find the constants, what do you have to do? So how did you find for c? How did you find for the lost constant? What did you do?
Um, I use the x and the y value that they give.
So you use the initial conditions, right?
Mm-hmm.
And you plug it in and you find for c,
Yeah.
right? So we got back the original expression.
Yeah.
Awesome. That's it. Let's move on to basic indefinite integration. I cannot show you the concept of integration. Let's actually start to integrate. So you all would need to know how to integrate x to the power n. That's quite simple. You're just adding 1 to the power and then dividing by that number. So copy this down fast. Actually, let me change up the questions here real quick. Um, right, so I kind of introduced you all to integration already, so you all should know what to do. When we are integrating, you're adding 1 to the power, and then you're dividing by that new power. So I'd like you all to try these 3 questions for me. All right, and any progress, guys? Any progress, Aliyah? How are things going?
Again, true.
You getting through? That's good. Like when you all 3 more minutes, 3 more minutes. Right on the name of this is basic indefinite integration, and that means integration without an upper or lower limits. All right, guys. Let me know what's going on. Let me know what's popping.
Um, I do the first two questions.
Mm-hmm.
I think I do the correct. This last one correct, I
So it's real
believe.
simple. All I had to do is add one to the power, and just divide by that new number.
So you're not doing anything with the tree, right?
If you want, you could simplify. You could simplify.
Okay,
Like if for instance I have 4/4, I wouldn't leave that as 4/4, right? That was what? It's 4/4.
one. Well,
Yeah. Yeah, one. 4/4 is one. Mm-hmm.
okay.
Oh, yeah, you send me working. Time is up. I would like everybody to send me what they have so far.
Yeah.
Amy, how the integration questions coming along? Easy?
Yeah, it's going good.
So the
So
only thing you shouldn't be able to solve right now is volume. And even volume real simple too. While they're working, let me show you how to do that. So if you want to find volume, so let me explain something quickly. Um, Amy, there, right?
yeah.
Imagine I had this graph. So if I find the area between x is 0 and let me just say 5, that'll be area under the curve. That's what integration is all about us to do.
Mm-hmm.
And that is what I show you the finite integration, where you put integral 5, 0, and you integrate it, and then you minus the low one, the upper and the lower limit, right?
Mm-hmm.
Well, volume, how would you create volume here? Well, to create volume, you would take this flat shape and you would rotate it 360 degrees. Are you not seeing the screen? You seeing the screen?
Yeah.
Right. So imagine if I take this flat shape and I were to rotate it, so I'm rotating it 360 degrees about the x-axis. So I take in the shape and I rotating it. Eventually, you form a what kind of shape?
One more triangle.
Hmm? Nah, it's forming a volume, right? Remember, we are taking it and we're rotating it 360 degrees. So,
Oh,
so if
okay.
you're looking at it from like, if you're looking at it directly, it will kind of look like that. And if you're looking at it like this, it will be like that. So what kind of shape is that?
Mm.
Yeah, it's a cone. So that's how you create volume. You create volume by rotating something about the x-axis. And you'll see them talking about that in the question, I don't want you to get confused. To actually find the volume, we need to do this. V is equal to pi, the integral, the upper limit, lower limit, whatever, whatever your expression for y is, you have to square it, and dx. That's it. So let me explain that again. This is what you're gonna use to find the volume. You have pi on the outside. So here what, Amy, you could work the expression like normal. You could work it like normal, right? And whatever your final answer is, you can multiply by pi. Remember, I showed you how you could pull out constants and put it on the outside.
Yeah, yeah.
Yeah, so pi on the outside. And y squared. Remember, we're finding volume. So when we square y, that'll be area. And when you integrate area, you get volume. So whatever the expression for y is, I would just say y is equal to x or something. You have to square this expression. So it will be x squared. You integrate like normal. You do the same steps. If you plug in b minus plug in a, and whatever your final answer is, you multiply by pi. That's how you find volume.
Okay.
So
Mm-hmm.
so you use this formula. V is equal to pi, upper limit, lower limit, y squared, dx. All right. Aliyah, let me check your working. So the first one, oh, Aliyah, you forget something, eh? Anytime we're doing indefinite
My
integration,
plus, my plus C.
right? Because remember, what if it had a constant before,
Yeah, my bad.
right? So, yeah, you're correct. You could do a little more work on that though, but you're correct. So for the first one, that is x to the power of 5, add 1 to the power, and you divide by that number, plus c. The second one, you have x to the power minus 1 all over minus 1, plus c. Now, is there any other way I could write this answer?
Um,
Was that
yeah,
positive divided by negative? Let me ask that
a
question.
negative, a
Yeah.
negative,
Aliyah, is the top value positive or negative?
negative.
How you say negative? It has a
Oh no,
negative power.
not negative.
It
Yeah,
has a negative power, but it is
positive.
positive.
Yeah,
If it had a negative sign in front, then that'll be different. So we have a
yeah.
positive divided by a negative. So we really just have negative x to the power minus 1. And x to the power minus 1 is the same thing as what? What is that as a fraction?
Um,
So remember, if x is negative and it's in the top, where would it be positive?
in the bottom,
Right. So
1
you
over x.
correct, 1 over x. Perfect. So we could write that as negative 1 over x
Oh, okay.
plus c. Awesome. And last one. Last one, we add 1 to the power, divide by that new number. The 3 and the 3 would cancel off. So we really have x cubed plus c. So you're 100% okay with that, right?
Yeah.
Right? And I have, so I'll allow you all to copy that down. And I have one more question here. Try question 4. Let me see if Ollie could figure out that one. Try to integrate a third x squared. Let me see what they're going to do. It's the same concept. I just think some of you all might get confused. Right, so Amy, I don't think any integration question should confuse you now. Well, I still in the area any volume questions might give some trouble because I didn't do anything with you. I didn't do a full question with you. But you're smart. I think you could figure it out. But I think it should be good for integration. You encounter any questions so far that give you trouble?
Um,
Nah?
Wait, it had one, but I don't think any. Um, it was to calculate the volume of a solid formed at the area enclosed by the curve y is equal to x squared plus 2 and the x-axis from x is equal to 0 and x is equal to 3 is rotated through 360 degrees about the x-axis.
Right.
That was
So
what you just did. So,
yeah, because imagine if you have a flat shape, right? If you have a flat shape and you take the flat shape and you rotate it 360 degrees, that's gonna make it a solid. And that solid is gonna make is a cone. Gonna make a cone. You understand?
mm-hmm.
Can you visualize that? Or like it hard to visualize?
No, I could visualize it.
So they told you between the x-axis and x's,
They say x is equal to 0 and x is equal to 3. No, x is equal to 0, so x is equal to 3. Right.
right? So your top value would be 3, your bottom value would be 0. And
Oh, that's
always,
what it means.
yeah, that's what I
Okay.
mean, right? And what was the expression for y?
Y is equal to x squared plus 2.
Right. So the formula says you have to use y squared. So this is y, so you have to square y. So y squared would be equal to x squared plus 2 all squared. And you use binomial expansion to expand that out. So that'll be
Oh,
x squared plus
okay.
2 by x squared plus 2, expand it, and then you integrate. Good?
Okay. Mm-hmm.
Right. Trust you have that.
Yeah.
Okay. All right, Alia, update my question forward.
I get wanted x cube
Mm-hmm.
over 3.
Right, but we need to write the answer in a different form. So you're correct. So
Yeah.
you have 1 over 3. So you have a third x cubed all over 3. That's
Yeah.
correct. Now, what is a third divided by 3? That is the same thing as saying a third multiplied by. So here we're saying, right? A third divided by 3. Divided by 3 is the same thing as multiplied by.
1 over 3.
Right, so where's that third by a third?
1/9.
1 over 9. So your final answer is 1 over 9 x cubed. That's how I expect it to answer these kind of questions. So
Okay.
when you get good, you just skip this working.
Yeah.
Right. So that's it. That's it for that's it for basic indefinite integration. That's any form x to the power n. So is anybody confused by these examples? Alia, Kirsten, Kira, you've come to class, but I haven't heard a word from you since. Is everything all right?
Yeah.
You come very early, by the way, I must say. You know, if you know, you know. Uh, did you do integration in school as yet?
Yeah, we started it.
So you know how to do this sign.
Yeah.
All right, cool. So let's move on. Oh, I had some more. Had some more questions. We're not finished yet. We have some more to do. Right. So we have 5, 6, and 7 to do before we start integrating multiples of a function, which we kind of do already. Um, yes, so Alia, I want you to try 5, 6, and 7 from now. See if you can figure it out. Kira, you too. Kira, I want to see working from you. Otherwise, I gotta talk to Miss Stacy. Right, so Alia, what do you think? If I integrate 5, what do you think I'll get?
You will get.
So was so let me look at something, right? Let me check out something.
Mm-hmm.
5 is the same thing as 5x to what power?
1,
No,
0, 0.
0. Because x, anything to the power
Oh,
of 0 is
0.
no. Mm-mm.
Wait,
But
what?
if that is the case, Alia, then
No,
5 by 0
wait.
is 0. Anything to the power of 0
It'll be
is
1.
is
1.
1. And then 5 by 1 is 5.
Yeah.
So anytime you see 5 or any constant, it's understood to be x to the power of 0. So
Mm-hmm.
apply the logic, you know. In integration, you add 1 to the power and then you divide by 1. Divide by what number it is. So do that.
Okay.
So when you integrate 5, you get,
5x
yeah, you get 5x. So anytime you
plus
integrate a constant, you just slap it on the variable tip. So if you
plus
integrate
c.
5, that's 5x plus c, right? Try question 6 now. Yes, Ollie, what was the first step in question 6? Could you tell me the first thing you did?
I changed the the square root
Mm-hmm.
to the power, so it'll be a half.
Correct. So the next thing you're supposed to write, right? It's supposed to be, since you didn't integrate it yet, you're supposed to write back the integral sign and put x to the power half. And then continue. You never drop the integration sign unless you integrate. In case there's a mistake you made. Did you make that mistake and drop the integration sign?
No,
Okay. So now you have the integral of x to the power half. Continue.
I add 1 to the power
Mm-hmm.
and I get x to the power 3 over 2 over 3 over 2 plus c.
Right. But we need to simplify this. What is 1 over 3 over 2?
1.
You're asking, right? Imagine if I had 1 over a half. What is 1 over a half?
Uh-huh.
No. Look, put it into your calculator.
Oh,
Look at what's going on, right? Over here, I'm saying 1 divided by a half. So what's divided by a half? Let's multiply by.
2 over
Right. Over here, I'm saying divide by 3 over 2, which is the same thing as multiply by.
2 over 3.
Right. So when you have a question like this, you're not gonna leave it like that. You're gonna say 2 over 3, and then you're gonna write x to the power 3 over 2. You don't need to write it in surd form. But let's do it anyways because we're very extra. We're very slow. Say on the sunny part will be 2/3, right? Because we're
Yeah,
saying divide by 3 over 2, it's multiply by the same
2.
thing, we're just flipping it.
Yeah,
2
yeah.
over 3. Okay, cool. So let's write 3 over 2 as a surd now. All right. So help me. What is the surd for that? Square roots, cube roots. Do you know?
Is cube root.
Nah, it's not cube root. Let me show you something. What is another way? I could write x to the power 3 over 2. I could write that as x to what power raised to what power? That's what I'm asking.
Um,
Remember, when you raise a power to a power, we multiply the powers, right? I'll give you an
yeah.
example. Nah, I'm gonna give you an example. You should figure this out because he did
Okay.
indices before.
Um, a half
Mm-hmm. So we have a half and raising that to a power. So
3.
what by a half is 3 over 2?
3.
Right? So x to the power a half is what? Cube root, square root, what is that?
X to the power half. That's square root.
Right? So we have the square root of x raised to what power?
3.
Yeah, that's it. If you're confused, watch this, right? We could have also said x to the power 3 raised to the power a half. Right?
Yeah,
So we'd have had so you have the cube root of, sorry. So you have the square root of x cubed. That's what you have.
yeah,
So for anybody confused, I'm gonna go over that one more time. If I have x to the power 3 over 2, that is the same thing as x to the power 3 all to the power half. Why, Aliyah? Why is this equivalent to this?
because When you multiply the powers
Yeah. There
all
is a power
together.
to a power you multiply.
Yeah.
So you end up with the square root of x cubed. And that's the answer. All right, so last question now. Try that one. Remember, if you didn't integrate yet, you have to write back the integral sign, put back the dx and everything. But remember, you have to simplify first before you could integrate. So try this question entirely by yourself. Well, yeah, how things looking? Hmm. This is more so like indices.
Um, well, I changed the third
So what power?
wanted.
Right?
So now I have to add 1 to the power
Wait,
on
wait, wait,
top.
wait, wait. Before you could integrate, you need to simplify it to x to some power.
Um, I
So
don't
you
know
have
what to
x
do
to the
then.
4 on top, and we have in the bottom.
X to the power wanted.
Right. What do you need to do next?
I don't know. Bring the x wanted. X to the power wanted on top.
How are you gonna do that?
You're multiplying. Wait, you multiply?
Take your time. So you're saying that so right, so you have x to the power 4
Mm-hmm.
all over x to the power third.
Yeah.
I don't want to tell you the answer because you need to figure this out. But the hint I'll give you is you need to before you could integrate, you need to have x to some power. This is what you need to have, this exact form.
Yeah.
But over here, you have an x here and an x here. You need to simplify. Try to figure it out. I don't care if it's
Okay.
taking 5 minutes, try to figure
Um,
it out by yourself. Hmm.
you'd have to divide the powers.
Divide the powers.
No, it's division.
Well, anytime we
So
divide and we had the
you
same base,
could
what do we do?
minus.
Okay, right? So somehow how that gonna look like? Actually, no. You do something and send me the working fit. You do that.
Okay, okay.
Yes, Aliyah, that's correct. That's what you're supposed to do. Good job. And you didn't lose no marks either. Good job. That's it. You did it by yourself, right?
Yeah,
Like, nice. So anytime we have the same base and you divide and we do the powers,
you minus.
right? So we're gonna put x to the power 4 minus a third dx. If you minus a third from 4, yeah.
11/3.
Right now it's in the form where we could integrate. So we add 1 to the power, right? And that'll be 14/3. So you end up with x to the power 14/3. And since you divided by 14/3, it's the same thing as multiplying by 3/14. So excellent job there. Really good job. Right? So that's it. Let's now start with integrating multiples of a function. And this is quite easy. We've done things like this before. Right? So Aliyah, all that means is we have a constant being multiplied by the expression. So imagine you have 4 multiplied by x to the power 5. Well, we know how to work that. And we know how to work that. You just add 1 to the power and divide. It's simple, right?
Yeah,
What I'm saying is we could also pull out the constant, put it on the outside, integrate like normal, and then multiply it back. So let me do that question on the board so they go actually understand it. So anytime we have a constant, what you are allowed to do, you are allowed to pull it out, right? So I'm going to pull out the 4, and I'm going to integrate like normal. So I pull out the 4, so I'm going to integrate x to the power 5 dx. So Aliyah, what's the next line? I'm going to integrate the x to the power 5 like normal. Without the,
so it'll be x⁻⁶/6
right?
plus c.
I'll put the plus on the outside,
Yeah,
right? And we're going to end up back with the 4/6 x to the power 6. That's my answer. Right.
Ali?
Well, yeah. Wait, it's gonna be harder.
No, the other question gonna be harder.
Yeah, I'm gonna give all that question to you.
Wow.
Try this one. So wait, so here what? You could do it in the method I showed you before. Like we did questions like that already. Like at two done thing. We know how to do
Mm-hmm.
it. But for this sake, I want you to pull out the constant. So what you're gonna do is you're gonna pull out the constant on the outside. So try that question. Amy, any questions giving you trouble?
You could just scroll up a little bit so I could.
Oh yeah, yeah, sure. I have access to everything. Yeah, Amy, any questions giving you trouble?
No, nothing so far. The only thing I just making sure that I'm doing the correct thing while I'm doing the weekend. So I don't reach that far. I'm 2013 right now.
Okay, but everything good, right?
Yeah.
Okay, well good. Good, that's good. Yeah, Leah, how things going? And Kira, I'm not getting any weekend from you either. I mean, not from you either. I'm not getting any weekend from you. Yeah, no weekend from Aliyah. Listen, I'm not getting any weekend from you as well. Right? Aliyah, you getting through a question too?
I pull out the what is call it? The minus 3/5.
Right as a constant. What do you do next?
I change the third.
Change the third. So if you have if you have this expression over here, that's counting as what power? That is what to the power what?
4.
Oh,
No, one quarter. Sorry, my bad.
1/4, right?
Yeah.
So this is what going on. We have x to the power 3 raised to the power a quarter. So what are we equal to?
3/4.
Yeah. Right, so it shouldn't give you
So
trouble. Continue. Should be fine.
it could be so now I'm gonna add 1 to the power,
Mm-hmm.
so that is 7/4
That's correct.
over 7/4
Yeah.
plus C, well, minus 3/5.
So you had the minus 3/5 on the outside.
Yeah,
So here what? Integrate everything on the inside first, and then once you integrate everything on the inside, then multiply it by the minus 3/5.
okay.
And you got something you're working.
Wait, so you're multiplying the minus 3/5 by the 4/7.
Yeah, yeah.
Okay,
Well, not the 4/7, huh? Watch. I'm gonna just remind you of something. Where is it? Look at this question. We had x to the power half, right? When you add 1 to the power, it was x to the power 3/2 divided by 3/2. If you're dividing by 3/2, that means you're multiplying by Alia. If we're dividing by
yeah,
3/2, is the same thing as
yeah.
multiplying by,
Um, if you divide them by it,
right?
you're
Okay, if
multiplying
you
by.
divide by 2, is the same thing as multiplying by.
Oh, aha,
So if I divide by a half, it's the same thing as multiplying by.
2. Wait, I'm gonna send you 1/2 because
Okay,
um,
so we have
just
right. So minus 3/5, x to the power 3/4, right? Then x to the power 7/4. Okay, yeah, yeah, yeah. I probably hit it wrong. 4/7. You have it correct there. You're going good. You're going good. You just have one more piece of working to do again.
multiply,
Mm-hmm.
multiply. Okay,
Yeah, right. So excellent job there, Alia. Excellent job. So let's do the working on the board. First thing you do, you're gonna pull out the minus 3/5. Because what do you call Alia? What's minus 3/5? Alia, what is minus 3/5? What do we call that? Doesn't have any x in
um,
it.
con
It's a constant.
coefficient, yeah,
Because you see
coefficient,
any x in this?
coefficient,
Is that constant?
yeah,
This is a coefficient. Is a coefficient of x to the power 3/4. Yeah,
yeah.
we're gonna call it a constant. So you pull it out, and that would leave you with this thing on the inside, right? But we need to convert that in a form where we could integrate. So let's do that. So the fourth root of the x cubed, that would be equal to x to the power 3 raised to what power?
A quarter.
Yeah. And if you use your rules of indices, that'll work out to be x to the power 3/4,
Yeah.
right? So right now we have negative 3/5 integral of x to the power 3 over 4 dx. Right, so in the next line, we are going to actually integrate. Now to integrate this, you're gonna have you're gonna add 1 to the power. And if you add 1 to 3 over 4, what power you get?
You get 7/4.
Right? Divided by 7 over 4.
Mm-hmm.
Right. Now dividing by 7 over 4 is the same thing as multiplying by.
4 sevens.
Right? So you're gonna end up with yeah, you're gonna end up with minus 3 by 4 is minus 12 over 35. And if we want to convert x to the power 7 over 4 to a third, how we doing now?
It could be the
So
4 root
whatever is in the denominator, that's the
is
root.
the root, yeah. So it will be 4 root, and that's what it's called, 4
Hmm.
root to x to the power 7.
That's correct. Excellent. That's your final answer. Simplified as it could get. Right. Awesome. So here what? Let's move on to more than one function. And this is very simple. Earlier, I just showing already formal methods. You don't have to do this, right? You don't have to do this. You don't have to separate it. You could just work it as it is. So let me look at this. So earlier, in this question, and you're seeing more than one. You're seeing more than one, right? You're seeing the 3x squared, you're seeing the minus 8x, you're seeing the 2.
Yeah.
But it's the same concept. You add in 1 to the power and you divide. 3x cubed over 3 minus 8x squared over 2 plus 2x. That's simple, right? Yes or no?
Yeah.
But the other method, what we're saying we could also do is we could also split it up into separate integrals. So I could separate the 3x squared, I could separate the minus 8x, and I could separate the 2. You just had to know it. You know how to use it. You had to know it. So copy this down. This is easy. Right? So Alia, I trust I copying this down and you understand everything here.
Yeah.
All right. Amy, how are things going with the integration questions?
It's going good so far.
Encounter any tricky questions?
Mm?
Did you encounter any tricky questions?
Not as yet. In 2013, it had a good question and I was trying to understand it. Um,
In 2013?
yeah, it was it was part C.
Let me check it out.
But again, true though. But it's a good question, you know?
Mm-hmm. Is
If
that
that making sense.
making you think?
Yeah. So and in the solutions it had the graph and stuff, so I'm copying that down too
All right.
while I'm doing questions. Mm-hmm.
2013. Find the integral of 5x squared plus 4. I guess then you get through that one. And and Timmy, and you get through it. 2013 question 6A.
Yeah.
All right. 2013 question 6B. That one might be a little tricky.
Oh no, I get you with
You,
that.
you made sure your calculator wasn't radians mode, right?
Yeah, yeah.
Anytime you see pi, radians. Part C. A curve passes through the point 0, 0.8 and 4, 0, and is such that dy dx is 2 minus 2x. Find the area of the finite region bounded by the curve in the first quadrant. Well, that's a nice question.
Yeah, that's what I was saying.
A little 8 marks. All right. So for this question, okay, so you know how to find area. When we're finding area, we integrate y. Do you have y?
Yeah.
Now we don't have y. We don't have an
No,
equation for y.
no, first, wait.
We have dy dx.
Oh yeah.
So my
Well,
question,
you integrate that to find for y.
mm-hmm.
Yeah. And then I take one of the points and I plug it in to find the equation.
Correct?
And well, after that, I found the area. Well, by using, it didn't matter which point you use, right? To
Oh,
have the upper and lower limit.
well, let's be very careful. It said find the area of the finite region
Oh,
bounded by the
no,
curve in the first quadrant.
it does matter. You
So
gotta
in
get a point in
first,
the first quadrant.
which point is in the first quadrant? 0, 0.8 or 4, 0?
Um, 40.
4, 0? Let me see. So 0, 0.8, 0, 0.8. Okay, that one wouldn't work. 0, 0.8 would
No,
be.
I said 40 was
Oh
in
no,
the
I
first.
just go into it. I just go into it.
Oh, okay.
Right? And 4, 0. 4, 0 would work because imagine you have a curve like that. Yeah, that would work.
Mm-hmm.
Alia, you
Yeah.
have everything copied down here?
Yeah.
Okay, nice. So now we're going to look at the integral of our products. This is also simple. In integration, before you could integrate, you need to simplify. I think you get that by now. So if you have a product, you would need to expand the product before you could integrate. So Alia, I'd like you to copy this down. Actually, try the question. Try the question. Do that. earlier. So try that one. So here I was saying, right? You have to expand it first and then integrate. So Amy, we could not use 0, 8 because that is only y-axis. If we wanted to find, get this right. So Amy, and you see how we rotate it about the x-axis?
Yeah.
You know, we could rotate it about the y-axis too, right? But that's a bit
Oh.
advanced. If you were rotating it about the y-axis, then you would use 0, 8. But we're rotating it about the x-axis, so we use 0, 0, 4.
Mm-hmm.
So what did you get from the equation for y?
Equation for I
Yeah,
got 2x minus x squared plus 8.
that's correct. And then integrating that within the limits 4 and 0, right?
Yeah.
Cool. Aliyah, how is the expansion going?
I get through. I get 3x cubed minus 15x.
That's correct. 3x cubed minus 15x, and what do you do next?
Well, now we're going to integrate.
Mm-hmm.
So that's 3x to the power 4 over 4 minus 15x squared over 2
Yeah.
plus c.
Right, and if you want, I mean, you could write your answer as 3 over 4. 6 over 4. So excellent job there, Aliyah. I would like you to try part 2 now.
Okay.
Right, so Aliyah, how you expanding that? Tell me, tell me, Aliyah, how we gonna expand that?
You multiply. Well, I doing. Um, I multiply the x squared by the 3x,
Right?
and then the x squared by the 2,
You going good?
and then the minus 7 by the 3x,
Right.
and the 7 by the 2.
7 or minus 7?
Minus 7, sorry.
Okay, cool.
So I get 3x cubed
So, yeah,
plus
3x
2x
cubed,
squared
3x cubed plus 2x
plus
squared.
2x squared minus 21x minus 14.
Don't forget to put the dx. Right, and if you
Okay.
integrate that way, you get.
Uh, Wait. Sorry. Hold on.
Now we can do one time. Let's do it fast. It's easy. You get
Okay.
3x to what power?
3x to the power 4 over 4
Right? Plus 2x.
plus 2x to the power 3 over 3 um minus 21x squared over 2
Right?
and then minus 14x plus c.
Good. That was really easy, right?
Yeah.
Right. Let me look at integral of a quotient now. Again, this is the same concept. What you need to do is you need to simplify as much as possible. As much as possible. That's the name of the game. And to simplify, you gotta have to use tools like factorization and all that. So Ali, I want you to try the first example. Integral of a quotient.
Okay.
You have ideas to what to do? How would
Well,
you how would you simplify that?
you could factorize the numerator,
Okay. What could we factorize from a numerator?
the x. So it could
All right,
be
so do that for me and see if anything cancel off and simplify it and then integrate.
x into x plus 5 over. Yeah, the x and the x. So it could be x plus 5.
The x and the x will cancel off and I go leave what?
X plus 5.
Yeah, that's correct. So factor out the x plus 5 all over x. Right, so we're gonna remain with the integral of x plus 5, and you should know how to integrate that. Easy peasy, lemon squeezy. How are we gonna integrate that?
um X squared over 2 plus 5x plus c.
X squared over 2 plus 5x.
Yeah, plus c.
Yeah, awesome. Um, I'd like you to try this question now. Wait, looking real long.
Uh,
Lucy, why it's so long? I just add extra steps to be honest. Like if
do
you
I
wanted,
have to do it like that?
now you don't have to do all the extra steps.
Okay, because I feel like that get timer up.
Just it's real simple. Let me give you some hints, right? Imagine if I had 1 plus 2 plus 3 all over 7. How much fractions I could split that up into?
3.
Right, so what's the fractions?
1 over 7,
Hmm.
2 over 7, and 3 over 7.
Right, they're using that same concept, but you're using the rules for indices to simplify it.
Okay. Um,
Right, how things going on here?
I think okay.
Okay, all
I
right.
simplify, I simplify, I simplify it,
Mm-hmm.
and I separate it into the three fractions.
Right.
I don't know, but I'm gonna send you just to make sure.
All right. I'm proud of you. You're well doing work today. That's good.
Yeah, feeling productive.
That's good.
Should totally tell mommy.
Yeah, probably shouldn't. Think
Yeah,
about
you
it.
should.
Let me see what you have here. So you have, nah, that's wrong. Is it a quarter x or x to the power a quarter?
Oh,
What is that? What are you doing, man?
I realized I know something was off.
Yeah,
I just
something was
didn't
off.
know what. Because then I was trying to figure out what to do with the X in the bottom.
Oh
Because I
my.
was looking back to the indices and I was like,
Fix it, fix it.
yeah, hold on. We talk too soon, you see?
Yeah, we did talk to some. All right, let me see what you have here. So you have 9x to the power 6 over x to the power a quarter. So you minus a quarter from power 6, right? So that'll be 23 over 4, 15 over 4, 7 over 4. You going good? Yeah, now you could actually integrate. Go ahead. Yeah, yeah. Let me know how things going. Amy, let me know how things going on your end too.
Enough.
Everything going good. Mhm.
I guess both of us say everything going good. All right, Aliyah, let me see the final answer. Well,
I
yeah,
didn't get a.
if we reduce to the 6 over 27, yeah, you get 4 over
Oh,
3.
yeah.
If you reduce it's over 19, you have that 4 by 11. Yeah, awesome. Good. Yes, our boss. All right, and now try this one. This is like, okay, right, and that'll be it. We nearly finished. Nearly finished. And then we can move on to some more advanced stuff. But that's basically it for integration of this is like you know how in differentiation you have to learn the product rule, the quotient rule, the chain rule, all them thing.
Yeah, yeah.
Well, this is what we do today in class, but for integration. So after today, you should be able to integrate anything you get. So copy down the example one and try to integrate part two using the integral of ax plus b to the power n. Anybody looking at this video, when you integrate ax plus b to the power n, that's just the opposite of a chain rule. Aliyah, I don't know if you remember this, but let me see if you do. Let me just say we have y is equal to 7x plus 3 to the power 9. Are you going to multiply that by itself 9 times?
No.
Okay, but if I had to differentiate that, let me just say I had to differentiate this. Why do you use to differentiate that again? Anytime you have a crazy big power, where you had to use to differentiate it? Which rule?
Um, she.
Chain rule. Do you remember the shorthand version of the chain rule?
And you taken out the 7x.
No. What you
Is it
do is
7x?
you take the power, put it in front, you differentiate the inside. If I differentiate the inside
Oh,
is 7,
7, yeah.
then I put back the 7x plus 3 and I minus 1 from the power. That's it.
Okay.
But what we're doing here is the opposite. Look at what we're doing. We're adding 1 to the power, we're dividing by the 7, multiply by the new power. Over here, we multiply by the power, then minus 1 from the power. Over here, we add in 1 to the power, and then we divide it.
And
It's
divide
just the
it.
opposite. So we're just
I
doing the
guess
opposite.
I just have to take my time.
Yeah. And you need to revise. That's what you need to do. You need to do questions.
Yeah.
All right, Aliyah, again, through question two.
Asanya, what do?
Oh, you submit. Okay.
Yeah,
All right. 5 minus 8x to the power minus 5 because you add 1 to the power. 5 by... Nah, that's wrong. That's wrong.
how?
Try to figure it out. Try to figure it out yourself. I need you to think for yourself. Try to figure it out. But I tell it wrong. I mean something wrong.
Oh, okay. I realize. Wait, I know what I do. I think.
So look at the formula. The formula is saying that
Yeah,
it's ax plus b. But so where you getting the a from?
the x from
Hmm.
8.
You get the x.
No, from the minus 8x, sorry.
Yeah. So it's really supposed to be minus 8. That's it. Good job. So if you wanted, you could have write this in the specific form because it's not in the exact form. So what I could have done is I could have said that this is equal to minus 8x plus 5 to the power minus 6 dx. And is this in the exact form now? Is this in the exact form of ax plus b?
Yeah.
Yeah, so ax is minus 8x and b is 5. Awesome. And n is 6, minus 6. So if we apply the rule, you end up with minus 8x plus 5 to the power minus 5. Because if you add 1 to minus 6 is
Minus 5.
1 less. So minus
Yeah.
5. And say, and you have a, the coefficient of a, we just now said it was minus 8. So that'll be
Mm-hmm.
minus 8.
By
And
5.
the new power is minus 5.
Minus 5.
So your final answer is
4.
minus 8x minus 8x plus 5 to the power minus 5.
Over 40.
Now, it didn't matter, right? Let me explain something. Some of you all, some of you all may not have had swapped this, but you still saw that it was in the form. So you didn't swap it, right? You continue with the 5 minus 8x. That is also correct. If your final answer is 5 minus 8x, that is also correct. Okay? If you
Okay.
want to be a little extra, this is what you could do. So Aliyah, this term here is negative on top. So where would it be positive?
And the denominator,
So I could
so
write
it
that
could
as
be
1 all over,
8x
nah, 1 over
plus.
40. 40 is already
Oh,
also in the denominator.
yeah.
Yeah, plus c, right?
Mm-hmm.
Yeah. So if you want to add in an extra part, sure. Why not? Right? You have everything?
Yeah.
Okay, so the last thing we're gonna look at is how to integrate sine x and cos x. So copy this down. So if you integrate cos, it's sine. If you integrate sine, negative cos. Pretty self-explanatory. So copy this down, and that'll be it for integration. Next class, we could start definite integration, which is area and volume, and then that'll be it. Amy, which year did you reach?
On 2015.
2015? Okay.
Yeah. I just have past A's with Google.
All right. Anything give you trouble again after that question?
Um, so for 2015, I was doing it, but my answers wasn't lining up with the solutions, but I could send you what I do.
2015. So now you do.
Mm.
So a spherical balloon of volume V is equal to 4 over 3 pi r cubed is being filled. Oh wait, no, that's already in the rate of change question.
Yeah.
So you get through with part A, right?
No, it was party. Hold on. Let me just
Okay, so if you
see.
integrate cos theta, it'll be sine x, sine theta. And you put
Yeah.
in, say you put in 3 sine pi over, maybe 3 sine pi over 3 minus 3 sine pi over 6.
Okay, that's what I have. But it wasn't lining up with these solutions. So
You had the answer in radians. You had the calculator in radians, right?
yeah, yeah.
All right, let me check the solutions out.
Oh, wait. I have PSA though.
Let me check it. 2015, right?
Yeah.
Okay, let's see what I'm doing. Oh, I make a mistake when I was writing the question. It's not supposed to be, it's supposed to be cos 3 theta, not
Oh,
3 cos
okay.
theta. So I'll fix that one time. Let's just fix
Okay.
that one time. Right. Amy, you see how I can make a mistake, right? This is cool. Check this. Um, 3. This was because, yeah, 6 now. And Amy, I didn't show you how to integrate that. Okay. So I guess we have one more thing to do on the sine and plus,
Okay.
right? So Alia, copy this down. So leave out that question for now. Yeah, so Alia, copy this down, and that'll be it for class today.
And the last one.
All right.
I finish.
Okay, nice. Right? Maybe I could try one time. I
What
want
was
to
that?
wait, give me a second. Uh, I have one more thing I need to show you for when you integrate in sine and cos. There's one more thing. and finance. Give me a moment. Right, so this is what I'm going to show you all. What this is, I promise this is the last thing. Additional, right. So Amy, I think this answers your question because it was because 3 theta. Amy. So the question is supposed to be cos 3 theta, right? So you had to integrate cos 3 theta. So to integrate cos 3 theta, you'd end up with 1 over 3 sine 3 theta. And then you apply the lower and upper limit, right? And if you want to integrate sine a theta, d theta, that would be equal to negative 1 over a cos a theta plus c, right? Right, so Amy, if I had cos 3 theta d theta, what would that be equal to?
I'd say the sine 3 theta, no,
Yeah,
3 theta. Mm-hmm.
right? What if I had the integral? What if I had the integral of negative sine 2 theta d theta? What do you reckon that would be?
A half cos 2 theta.
Right, that would be a half because we have a negative sign here. So because when you integrate sine, you get negative. So if you integrate negative sign, you get a positive. So that'll be
Mm.
1 over 2 cos 2 theta plus c. Yeah, I believe that's it. All right, so that's it for the integration. Aliyah, you have any questions?
No.
No? Well, that's it for class today. Thank you for coming to class, everybody. I will see you all. I'll see some earlier, but Amy, I'll see you tomorrow. And I'll see the rest of you all Tuesday and Friday. Yeah. Later, everybody. Have a good day.
Bye.
Bye.